So lecture number 20, today I'll be talking about saving and loading games. I've had a number of questions from students about the project in terms of, like, how should I save my game, right? Like, should I have checkpoints? Should I have, like, arbitrary quick saving and stuff? And we'll get into that and some ideas for the project, as well as the idea of game tools. And then at the end, I've got drag and drop here because in previous offerings of the course, up until this point, we hadn't had the mouse actions in our action system. But since we have that now, that's going to become this like live coding, freeform live coding session, and I'll show you some ideas for the level editor. So we'll talk about drag and drop, of course, but it'll be mostly me demoing you like an incomplete level editor so you have some ideas for your project. So as part of the project, we have this notion of game progression, meaning that you're going to have some levels in your game. Those are either going to be incomplete or complete. And of course, if you're making a bigger game or a more complex game, that's going to be even more complex. And in order to store your progression somehow, you need to talk about what sort of data you're going to be saving, what methods you're going to be using to save your games, etc. So yeah, we want to talk about those things in this lecture. I'm just trying to turn on this external mic, and it is out of batteries. All right. So, game saving. So a vital part of any game is the ability to save the player's progress at some point. Turns out that that's going to be completely different based on game mechanics. So again, all of these things that we do as programmers, we're just implementing something that a game designer has told us to do. And this is going to be heavily dependent on the mechanics of the game. It can be implemented in a number of different ways. So you can save to a file, meaning that you actually get a physical file, which is like Dave's save01 .txt. You could have a quick save, which is like, it doesn't necessarily get saved to a file, but it might be just saved in memory, where you allow players to load or save the state of a game. You could have a checkpoint in the middle of a level. So we're talking about like some different Mario games where, okay, you've gotten through the hard section, here's a little rest stop with a checkpoint in it so that if you die past this, you can go back to that checkpoint or midpoint of the game. And they can be stored in a number of ways. So local file, nowadays you have cloud save with services like Steam, Epic Games, all these things. You could have temporary saves, so these are just in RAM that are, once you stop playing the game, that's not going to be there anymore. And we actually have password saves as well. I'm going to have a video that we won't watch, but I'll link in the timeline as well and talk a little bit about password saves and why they were necessary back in the day. So like I just said, when and how you allow players to save their progress in the game, that is a game design decision. Saving and loading whenever you want, that could lead to like really easy gameplay. Right? So I remember playing like Half-Life back in the day. So I have two stories. One is a quick load and quick save story. So I was playing Half-Life and first-person shooter, late 90s. And you could press like F5 to quick save and then like F6 to quick load. Or the buttons were close to each other. Can't remember, but it was some of the F keys. And so I'd get past like 3 enemies and quick save, and then get past like 3 more enemies and quick save, or enter a new area, quick save, etc. And that made the game a lot easier and led me to like experiment more, like, oh, what's over here? Oh, I got stuck trying to get out of bounds, I can quick load. But then my brain had a brain fart, and with an enemy rocket about to explode on me, I quick saved. And so I died and then loaded, and didn't realize I had loaded, and now so my save was me about to die and completely soft locked the game, and that was my only save. And so always make sure that you have multiple copies of a save when you're so far into a game. You could save at like a checkpoint system where you reach like the middle of the level. And so in like Super Mario World, for example, I think that was the first Mario game that had a checkpoint maybe for the Super Nintendo. And you run through this little gate and a sound plays, and if you died after that, you would come back to the midpoint of the level. And then typically with these, if you finish the level, then the next time you play the level, if you play it again, you would start back at the beginning. You could also have saving only at specific locations, town or camp, etc. So for example, this is pretty typical in RPGs where you have different scenes. Like you would have a main overworld scene where you're walking around. And typically when you're out in the main world, you could save wherever you wanted, right? So you can use your tent to heal your party up. You could save before you enter that dungeon. But you probably wouldn't want the player to be able to save and load like in the middle of a boss battle, right? Because you could manipulate the RNG, you could get critical hits all the time. So when you actually save is a real design decision. And my other story that I kind of wanted to tell, which is maybe you've encountered this, maybe you haven't. So I remember the day I got a PlayStation 1. And so I had a PlayStation 1, and it was like I had to convince my parents to like buy me the PlayStation. And it's like, oh, now I need like a second controller in case someone wants to play with me. And I got an RPG called Wild Arms. And Wild Arms was a game that came out just before Final Fantasy VII. So it never got all the respect that it deserved because it was quickly overshadowed by Final Fantasy VII. But after convincing the parents to like buy all this stuff, I was like, and I need a memory card. Because you couldn't save to the disk, and there was no storage in the system, so you actually had to physically plug in this memory card that had a couple of megabytes of storage to save your games. And they're like, oh yeah, and what's next, and what's next? So they're like, that's it, no memory card, save up your money, buy a memory card. So I had to leave my PlayStation on overnight so that I wouldn't lose my progress in this game. And of course I would like bump the PlayStation and it would like skip the disk, and then that was it. I had to restart. So I played the intro to Wild Arms about 8 times before I had a memory card, but I got really good at the beginning of it. So, you know, nowadays, yes, games still come on disk, but there's like hard drive space somewhere that would let you store all these files. You don't need to go buy a separate memory card. But I still have my original PS1 memory card. I'm not sure if it works, but it's in a drawer at home. So that's, geez, how old now? 25, 26 years? I don't even want to think about it. Okay, so that was sort of an overview of all the different types that you could do. Now let's look into the details of a few of them. So saving between levels. This is probably the easiest way to implement any sort of progression, right? So if your game is chopped up into individual levels, like think, you know, Super Mario Bros. 1, some platformer where I start at a location, I have to touch a flag, and then I like enter the castle or whatever, and it goes, oh, I'm level 1-1, level 1-2. And so implementing how to save the game between levels is probably the easiest thing that you could imagine. There's no entities active in the world, there's nothing happening, there's nothing going on, you're not currently playing the game. So you could literally just store like the integer of the level that you're on. And then the next time the player comes back into the game, you just load that integer, okay, they're on level 3, right? So you load level 3, you let them play. So this might be the easiest possible thing. So in simple games, if you don't have quests, you don't have inventories, you don't have items, you don't have status, you can just save the level number that you're on and it's fine. So I just made a mistake. I just said that, let's say we're playing Super Mario Bros. 1. All we would need to do is save the level that we're on, right? So I could just save, okay, we're in World 4, level 3. But what else would we need to save in that game? Oh. Yeah, so like, how many lives do I have? Maybe I have 10 lives left, maybe I only have 1. You said state, I think, like, so you could have a fire flower, you could have not, you could be small. And so yes, there are some other things that you would have to actually consider in that game. Now that you've been able, you know, you can save progress, but you have to be able to display and effectively communicate progress to the user somehow as well. And this sort of, you know, this is sort of a user interface, user experience sort of topic, so I'm not going to get too much into it because this is not a UX course or a game design course. This is more of a game programming course. But you have to, you know, their progress must be conveyed to them somehow so that they can continue from where they last started off or last left off, or they could decide to reset or restart or something like that. So the simplest way to display user progress is like some level number. Right? So over here, we have Donkey Kong. It's on, oh, you're on level 1. Over here, World 3-1. You have this many lives left. It's a terrible example. Why did I choose this? So this is like the characters that would display text in Super Mario Brothers came from this like static array of textures for all the different things. And if you went above that, it was just reading data from other textures. And so this person has so many lives that they're not able to correctly display them. Yeah, just level number display, pretty easy. Another common way is to display progress as a sort of overworld map. And that conveys like a deeper sense of immersion, progress, etc. So I'm going to go back to, you can tell how old I am because these are all from my childhood. I think that's when you know, all these memories get formed. And so I'm going to show these examples. These are from the Super Nintendo. And this is Donkey Kong Country, probably one of my favorite games of all time. And this is Super Mario World. This is a view of the world of Super Mario. And the video, I think it's the Video Game Historian, has a really interesting video on the creation of Super Mario World and how this map sort of evolved over time. It's a really interesting video. But this is just like one step beyond the level number, right? So there is more information being stored here because these are not necessarily linear paths, right? So you have to say, okay, I couldn't just store, like for example, over here in Super Mario World, I couldn't just store that the user is sort of on this level because there are different paths to get to that level. And so maybe like I had skipped this level or not. And so the overworld map is sort of a graph that you're displaying to the user somehow. And then the nodes of that graph are like annotated with, has the user finished this level or not? And the edges between the nodes on that graph are like saying, okay, I can traverse from this level to another level. And that's the same thing over here. For a more modern example of this, we have Cuphead. And so back in these games, probably limited by, you know, technology at the time or a game design decision, but in these levels, this was like a different kind of mechanic here where you could like, if I press up at a specific, like if I'm at this level right here and I press right, I will go straight to this level. Like I can't arbitrarily walk around on that screen, but I can move between the nodes on this graph. But in Cuphead, for example, you're able to move around sort of freely in this world map, and that offers a couple of things. One, you can actually discover little hidden secrets where you might find a coin behind a tree or something like that. But it also is a kind of a more immersive sense of discovery of that world. Like I'm actually walking around in this world. I can get into shops. Like there's a shop here, for example, where I can spend my currency, etc. So it's a really nice, I think, really nice break from the gameplay. Like you're generally going to be pretty safe here. It's like a decision-making thing. You can review your progress, but you're not like actively dodging bullets or anything like that. And a big part of game design is this sort of roller coaster of emotions where it's like intense action and then a break from that action. Like nobody wants to be speed running 24/7. You want a little bit of a break, go to the bathroom, whatever, and this sort of overworld map is a good way to do that. Here, the user is visiting shop, I think. I actually haven't played Cuphead. I've watched a lot of it, but I haven't played it. And so the progress that we've made is also displayed here, and it feels really good because all of these things, this currency, for example, that I've been collecting by either beating the levels or collecting in the levels, these are stored in some global way so that now when I get to a shop, I can unlock levels or power-ups or whatever. So this sort of currency system is one of the things that you can implement as the, not a bonus marks, but one of the extra things for the project is like a currency system where on the overworld map, okay, between levels, I could go over here, I could spend some gold, etc. Anyone here know what this game is? Or played it? Okay, so you'd know it immediately. This is Path of Exile. So Path of Exile, that, you know, I like to stir up some drama by calling it Diablo for adults, right? So, yeah. And so there are like hundreds, this is the atlas, or it's an old screenshot whenever I made these slides of how the atlas used to look. And what happens here is each of these little nodes is a map. It's called a map. And so you get these items in the game, which are map items, and it's like, oh, okay, I go to my, I forget the name of the, you know, in my hideout, I have this device. I put the map file or the map item into the device, and then I go visit that map and I can clear it. And when you've cleared it, then the icon appears in the atlas, right? And you can, when you're in a map, you can get a drop that's any of the adjacent maps, and you try and make your way from the outside in or the inside out or whatever the flavor of the atlas happens to be in the current patch. But this is another way to like save and visualize your progress, and it feels good to like see this being filled out as time goes on, and you can see your progress like that. This is from Heroes of the Storm, and so this is a MOBA game made by Blizzard. And here you're showing your progress. So in a game, like a MOBA game, or maybe an online shooter like Call of Duty or Halo or something like that, there's not really this concept of levels, right? Like a multiplayer game, you kind of play a game against some people and then that game is done. And then maybe you play a game on a different map or on a different level or whatever, but it's like a sequence of independent things that happen. And so, you know, back in the day, you would just like play a game of Quake or Doom or something like this, and you would play it, you'd shoot a bunch of people, oh, I won or I lost, and then that was it, right? You just stopped the game. But in this system, what happens nowadays, people want progress. You know, you've played a game for a long time, you want to kind of see something for that. And so a typical mechanic that's used to implement progress in one of these sort of independent event type games is the idea of experience or leveling up, right? So I've played a game, I got a bunch of experience, maybe at level 2, I've unlocked, I think here, for example, you unlock a new skin after a certain amount of experience, or, you know, you get this, you didn't have your hero's most powerful ability until you reach level 6. I think, I can't remember in League of Legends, you know, when you unlock Flash for the first time, and now you can actually play the game because you have this ability that lets you survive or whatever. So that was the overworld map, or for example, an RPG game may have like a save point, and I have some slides on that, so I'll talk about RPG saving in a bit. Saving is one thing. This happened more in older games, but the idea, instead of saving, continuing. Okay, so you have died, you've run out of lives. So it's interesting that lives as a mechanic turned out to be kind of a bad mechanic, right? No one wants to be playing a game for so long and then just, oh, I died, now I have to start from the beginning again. So it's an interesting gameplay design decision to have lives or be able to have infinite lives or restart from wherever you want, but back in the day before saving games was really possible, and I'm talking like this is a long time ago, instead of like saving to a file that you could load up the next time you played, for example, Super Mario Brothers had continuing, right? So if you died in World 4.3, it would let you continue back at World 4.1. But if you turned off the system, you would be back at the start of the game, right? So it let you continue from some sort of point from a gameplay design decision. So if you don't want to, or you can't implement a full type of save for your game, this continuing system, continuing from a given spot was a decent system. And this would be like non-persistent saving. So it is a type of saving, but it's not saved to a file or anything like that. So would you let them restart a level? Would you let them restart a world, etc.? All these are different decisions that you can make. Very common in early video games when arbitrarily save game functionality may not have been possible. So maybe there's too much stuff going on in the game to be able to save it to like whatever flash memory is on the cart for an NES game or something like that, or maybe you just don't want them to be able to save. So who knows which game this is? Zelda. Yeah, so that's the game that we're making, right? So that's the original Zelda's continue screen. And so you could actually save in this game. And this is kind of a bad example because this continue, you could accomplish the same thing as this continue by just restarting the game and loading your save game, right? So this continue just means, for example, load the game from where I last saved. But it is still an example of continue. What a lot of people overlook is where continue was actually not a game design decision. I mean, it was a game design decision, but this was like a business decision as well. So what this is from either Final Fight, yeah, I think this is from Final Fight or something like that. And what happened here is you ran out of lives. This was in an arcade machine, right? Now, when they ported them to consoles, they had the same sort of system, but once you've bought a console game, they have all the money they're ever going to get from you. So this is just a holdover from arcade games. And what happened was you lost your 3 lives. They want you to put another quarter in. So what they're going to do is create some sense of dread. You know, oh, if you don't put another quarter in and continue from where you last saved, this guy's going to get blown up, or Chun-Li's going to get really sad. Look at it, you know, she's crying, you don't want her to cry, put in another quarter, put in another quarter. Some games would actually like call you a wimp, like insult you to put more money in the game. Like, so this was actually like a combined business / game design decision here when it comes to this sort of continuing. And this is because, now, in my opinion, game companies today wished that they had this business model of every game you put in a quarter, right? But that was the only way you could play games back in the day because of hardware limitations and stuff. So I don't know. You know, there's lots of, maybe there'll be some arcade game, you know, released online where you got to swipe your credit card to continue, but, you know, whatever. And there's lots of different game over and continue screens that have been in all sorts of games. And, you know, I'm obviously showing retro games here because those are my favorite type of games. Did you have a question or?
No, just
oh, okay, I thought just out of the corner of my eye I saw it go up. So another type of saving is called a save point. And what a save point does is it makes it easier to implement game saving and loading by limiting the places where players can save and load. So these are typically static locations that you have specifically chosen to be away from other entities, dangerous situations, etc. And there are old school examples of this that I'll show, and also newer school examples of this that I've shown. And this allows us to save the game without worrying about things like entity storage. So what do I mean by this? Okay, here's a great example from Final Fantasy VI, where we want the user to be able to save the game, but we don't want them to be able to save at like an arbitrary location, like I talked about before, like in the middle of a boss battle, or somewhere where they could like quickly save and load to manipulate some random numbers or something like that. So here we've got something, it looks like they're in a cave. So this player here has come in from the left. They can only exit from the right. And oh look, so as an RPG player, what do we know is about to happen in this game right now? There's going to be a boss battle, right? So you enter this area and it's like, you better heal up here, right? And so this is cool. It's cool for so many reasons that people, I think, often overlook. And I think that the fact that we overlook it means that it's good design, right? Because good design shouldn't slap you in the face. It should just be ubiquitous. And so here, what's happening is you have chosen an area. Like, let's say our RPG has like enemies walking around, right? And if we bump into one, then it starts a battle. We wouldn't want to be able to save in that place arbitrarily, or even with a save point, because while we're saving, maybe something bumps into us, etc. So we have created an area where nothing else could happen. So nothing else is going on here. It's just a background image and a sprite maybe for the save location. But all we have to save here is like our character stats and maybe some integer, which is representing the save location that we are currently at, right? And so no, there's no entities here. There's no anything. Also, sort of the ominousness of this save location, like we just said, we can sort of predict the gameplay that's about to happen by the fact that this thing exists, right? And so it's a meme for a reason. It's because, you know, the game designers have liked it this way.
My second favorite game.
Oh yeah, it's really great. The only thing I didn't like about Final Fantasy VI, and I like this about some games and don't like it about other games, is when you're going full completionist mode, there are things you can miss that you can't go back to collect, right? And it just gives me anxiety. Or like items that you can steal and like all this kind of stuff. Okay, so save points, that was one example. You know, these go right up to modern RPGs, so these are in a bunch of different games that you've played. Now, a much more modern example of this would be a bonfire in a Dark Souls type of game. This is essentially an old school save point. It's just implemented in a much more modern way, right? So like some of the Soulsborne, Sekiro type games, I can't remember if like, you know, can you use a bonfire to actively escape from an enemy hitting you, or do you have to be out of combat to use them? That is a game design decision, right? You might like picture a bonfire like this with a little zone around it where if you're running away, then it saves you from an enemy. Or maybe you would want the player to not be able to just speed run through a level to get to the bonfire. So if there's enemies still, you know, are aggressive towards you, you would have to kill them before you use the bonfire, etc. But this is basically a place where you can save your progress and like figuratively and literally take a break. right? So it's cool because these things back here, like you look at this, this example, this is like an area where if you were out in the wild, you would want to rest here. You would actually probably set up your tent here, right? You'd maybe barricade the doors or whatever. And so this is good gameplay mechanics because it communicates what you're supposed to do via the visuals and the feeling and stuff. So, you know, I'm not an expert in game design, but I know good game design when I see it, and this sort of thing is good game design. This is also examples here from Castlevania and the Metroid series, where you literally go into another room where nothing else is to save your game. Checkpoints are another type of system. And so if you have a game that is separated into like individual levels, sometimes those levels are really hard by choice. And so you might want to implement a system that lets a user save their progress within that level in some way, and checkpoints are a good way to do that. So it reduces frustration from players by allowing them to save their progress. And what it doesn't do is it doesn't allow the players to make quick saves, right? Like you could just allow them to, like I said, press F5 or press L2 or something to save the game and load the game instantly. But what a checkpoint does is it doesn't allow you to do that sort of manipulation that you could do with those sort of quick load and quick save systems. So over here, there's examples from the Sonic series and Super Mario series, where if I run into, so if you see a checkpoint, you know that you're probably at the halfway point of the level. So the interesting thing, I think, is that making these checkpoints optional, right? So maybe the checkpoint is sort of out of the way. So if you're like speed running the game, you might avoid the checkpoint because it would take more time. Like, why wouldn't you want a checkpoint, right? But you can jump over it if you want to. So there's making the checkpoint optional or making it not optional. What's that? Mandatory are game design decisions. And of course, here's an example from Shovel Knight where it is, you have to break this thing, and that is like a very intentional decision.
I think if you break it, you lose the checkpoint. You get a bunch of rewards if you break it.
Oh, I see. So this is another game design. So again, haven't played a lot of Shovel Knight. I did, but it was years ago. So that's an example. Let's say we're making a game, right? And so if that is true, then you can get the midway point or you can discard it for some sort of reward. So this risk versus reward associated with checkpoints, that's really cool. So checkpoints are pretty easy to implement. If a level has a finite number of checkpoints, just store the checkpoint number, right? So I've got I've got 3 checkpoints in my level. They last touch checkpoint 2. So in addition to saving the level number that we're on, I would also save the checkpoint number as well. And when a player enters a level, just spawn them at the position of the last checkpoint that they saved. And then when the level's completed, maybe you want to reset the checkpoints, maybe you don't. Autosave. A lot of modern games have switched from, explicitly saving your game to automatic saving. And I find myself more annoyed by this than not annoyed by this. I sort of want to be able to create my own save file, and then maybe, if I made a decision I didn't want to do, like, oops, I accidentally shot that vendor in the face, and now the whole town hates me, and then I accidentally walked out of the store, and now it's saved my game forever? Like, okay, whether autosave is... But the thing that autosave does is it removes that disconnect, right, of... I'm playing a game, I'm immersed in a world, now I have to hit a save button. Like, that's a little immersion breaking, right? So it does that, but sometimes it can be annoying. And so it's nearly identical to checkpoints, but it just happens invisibly behind the scene. You just create some invisible checkpoint, essentially, that you're auto-saving at. And these gameplay decisions on when to save, player enters a new zone, player kills a boss, player picks up an item, it's all gameplay stuff. It shouldn't be much different in its implementation, but when you decide to do that, of course, is interesting. And then, of course, we see stuff like this. This game saves automatically, don't turn it off. When you see this light blinking, don't pull the memory card out. Like, I remember, when you had memory cards, it would say, saving game, do not remove the memory card, right? And it's like, what kind of psychopath hits save and then is like just jamming their memory card in and out of the system? It's like, you know, when you go on an airplane and you get the peanuts or pretzels and it's like not for resale, right? Like I didn't even think about doing that until you told me to. And so the reason this exists is because, you know, now that you have been reading and writing from files in your CS degree, what would happen if you unplugged the hard drive as a file was being written? Well, you're going to corrupt your save game, right? Possibly, because you were, you know, you had written the first 20 bytes of the 50 bytes of information that your save file needed to write, and now it's completely corrupted. So this is important to communicate to your user, but at the same time, no one would have done that. Anyway, and there are ways to get around save file corruption. So one of the ways that a lot of, and save file corruption is not just in games, it's in pretty much any application, right? You want to save some state or some config. And so what happens a lot of the time is that, let's say we have a, you know, save state.txt and we want to write to that. Next time we launch the application, we load our state from that. So one of the ways that you can never truly avoid the possibility of it corrupting, but what people do is they will save the current state to a temporary file so that if lightning hits your house or whatever, and it interrupts the writing of that file, which does take some amount of time, so it could happen, then you still at least have the backup one, right? You have the one that you had before. So you could corrupt the new one, but that's not important, because what happens is once you have saved that file and verified the contents of that file are correct, then you just rename it to the old file, right? And you could even say, okay, take the previous one and rename that to like previous save, and now you just rename the other one. So the process of renaming a file is a lot quicker than the process of writing everything to that file. So there are ways that you can save backups and stuff like this so that you don't just have a, you know, one, you know, ray from the sun or, you know, something like that just completely corrupts your save data. So we've been talking about all this, but now you have to say, okay, I have to implement this. What data do I actually save? And which data to save depends on the type of saving that you want in your game. We've talked about this a little already. So for example, if you're saving between levels, then you would want to store like your current levels completed, your inventory, your weapons, your Mario power-up state, whatever. If you're saving at a save point, then typically this type of game might have some sort of quests completed, party stats, which save point you used, etc. In a quick save, typically a quick save is like saving like a snapshot of the game, right? So in our game engine, if you did implement some sort of quick save and quick load, what you could do is just have something like in the entity manager that allowed you to save and load the state of all the entities, right? So picture you just come up with some syntax for saving an entity to a file. Then you just go through the entity manager, save all those entities to a file, and then when you want to load, you load that file, you put all the properties into, for each line, you would maybe create an entity, and then put those properties back into the entity, and now you've got a quick save and quick load at any arbitrary state during your game. Loading the save game, of course, in the same way, implementing loading a save game depends on what data was saved. If just the level or items were stored, then you could recreate the game state before that level starts. So you would just say, like in our current game engine, load level 2 or whatever. If you're quick saving, you may have to load all the entities back into the game. So here's an example. If you have a sort of overworld map view that we just gave an example of, the saved game here would store maybe the levels completed, the current status of Mario in terms of you know, what power up you currently have, whether or not you have a cape, maybe you have a fire flower saved in your inventory box. Maybe you have an inventory of items like Super Mario Bros. 3. I know all of these examples are archaic, but they're just the most intuitive. And then when the game is loaded, you can put Mario back on the overworld map with the completed maps shown. So for maybe like a level you haven't completed is in green. Maybe if you have completed it, it's red or something like that, and so you draw all that stuff. And then loading the game may require you to quit to the main menu again or something like that. Who knows, like how you've implemented stuff. An example from quick saving, and quick saving is not something I've seen in a lot of console games. It's mostly like PC games that I've seen quick saving. So you could press a button to instantly save. When the quick load happens, then you've implemented somehow of just saving everything relevant to the current game state, and then you just load all of that back into the data. Now, a really cool thing is that because in an ECS system, all of our entities are composed of components, and those components are pure data, what you could do is just write the raw bytes of all the components to a file, and then load all the raw bytes of the components to a file. So if you were saving to a binary format like that, you wouldn't even have to spend time coming up with a syntax for your files that is like human readable, because you could just write the raw bytes of an entity to a file and then load the raw bytes of an entity from a file. For your project though, I would like you to come up with some human readable syntax for saving so that I can see that you've actually done it. But just again, know that a gameplay decision is that, you could abuse this to get past difficult areas, know the outcome of some RNG, etc. Password save absolutely fascinates me, and as a kid, I remember trying to break passwords. I was 5 or 6, and I was like, if this was the password for level 1, if I add another 1 to it, do I get to level 2? What does this password mean, etc. So password save basically came out of necessity, right? Nobody wants to have to write a password save. It's essentially a hash function, right? So what happened was these older games didn't have any memory on the cart, or if they did, that memory was an old school type of storage that had to have a battery in the cart to actually keep the electricity flowing in the cart a little bit to save things. And so this was all because you couldn't save a game to a file. And so what happens is you get these things where, okay, I'm going to type in a password, and this password is somehow going to encode all of that information that I would have saved to a file, right? And so that's a process called hashing. So for example, something about a password is that, well, you don't want the user to know how the passwords are generated. Because like I just said, okay, if I'm on level 4.3 and the password was just 4.3, well, maybe now if I type in 4.4, I've beaten a level for free because I've figured out how the password system works. Over here in the earlier Mega Man games, instead of having numerical or alphanumerical passwords that you type in, this is like dots on a grid. Now, why did they do that? Who knows? It's just more technology-like or something. It's just an aesthetic choice. But essentially, you can view this as a binary number, right? So it's like 00001, 0101, etc. Excuse me. How those passwords are actually stored are different, drastically different, depending on the game, right? So for example, some of those bits, maybe there's some encryption or decryption that you have to apply some key to the thing, and then you take these bits and you XOR them with other bits, and that gives you the level number. Then you XOR it with something else, and that gives you the current power-up state, etc. There's a YouTube series called Cracking Video Game Passwords, and this is by the YouTuber Biscuit, who's a prodigy of programming. He's insane. This guy's insane. But his YouTube channel is truly excellent if you're interested in low-level game stuff. And this video here, which I won't play in class because I want to get to the live coding stuff before time runs out, but I'll put that, in the timeline of the video, and you should watch this because it's really interesting. And he has a whole playlist of 10 different NES games where he looks at the code and reverse engineers the passwords. All right, game tools. Jeez, I'm rambling, so I may not get to enough of the live coding that I think. Game tools. So as you make more and more games, you quickly learn that content creation becomes the big bottleneck, right? Writing the code, we've got the game engine done. Okay, time to make a game now, right? And so creating that content, testing games, etc., becomes the most time-consuming part of the game development. So tools are programs that assist us with creating content for our games, right? And tools can come in many, many different flavors, and not just specific to game programming, but something like Photoshop, Blender, pixel art, Notepad. These are all tools that help us make games. Some of them are just more specifically designed for games than not. And for more specific asset creation, maps, levels, etc., we may want to, or I say need here, but we may want to construct our own tools in order to help us with that. And of course, we are well aware that, in modern 2024 times, lots of different game engines exist. And so if you were actually going to go out there and make a game that you would want to sell and debug and have on different platforms, I would highly recommend just using a game engine, right? Like, that's the quickest way to get to market. It's the most painless way, etc. And so several different game engines exist, and they help you. They're very general game-making machines that have lots of tools in there for asset creation, how to zip those up, put it into a nice package that could run on Android or a Mac or a PC or whatever. And they do a great job of illustrating the power of tools for game creation. So here's an example of a level editor or a scene editor in one of these game engines. So here we're making some sort of level for some game. So this is isometric view, 2.5D type of game. And so this is an example of a level editor that either comes with this game engine or someone has made within the game engine. Another example here, I think these are just old versions of Unity, I'm not sure, but here we've got some sort of painting tool in this 3D game software that allows us to paint things on the ground, oh, I want some trees here, or some bushes here, or a road here. And you can see that this road actually deforms the ground, etc. We also have tools that lets us build up terrain. So of course, if we were making a true 3D game, we would not make a level like we have been making them in this course so far, where it's okay, I have a tile at 3,4, right? That would be insane to try and type in all these vertices and blades of grass and all that kind of thing. So tools would help us with that sort of creation. Here's just another example that I like of, this tool is so advanced that, there's some procedural content going on here where I move the road around, trees pop in and out based on that road. Modern game engines typically have some sort of blueprinting system where even things as complex as behaviors and coding can be done visually just by linking things together, right? So here I think they're designing a shader where all the different options for the shader are just in these drop-down menus, and you can just drag and drop and say, okay, I'm going to apply this thing and then that thing, and it's all visual, it's all a tool. And what these tools do is just take burden off of game programmers and game designers. So if your game is not using a pre-existing engine, that you probably have to create some of your own tools. Like we're going to make a level editor, right? And hopefully you'll see that once you've made that level editor, the process of making levels is hopefully easier now than it was without it. If it's not easier, why do it, right? So many existing games, especially older games, come with level editors and tools for modding those games. Now this is an art that is absolutely dying out, the fact that games come with level editors. But the feature and power of these tools vary wildly from game to game. This is the first one I ever used, and it was for Warcraft 2. And you can see here the copyright 1995, so showing my age here a bit. I was 12 in 1995. But this game came with a level editor. You could make your own levels. You could play against your friends on those levels. It was the most mind-blowing thing ever. Quake here, this is Doom Builder. So this is a tool that someone made for creating and modifying Doom levels. This is one for Quake. So this is a 3D editor. So here you've got like the top, the back, and the side view for all your different degrees of freedom, and then a little 3D view of what you're doing. I remember being so mind blown when I first used a Quake level editor in the late 90s, and I'm like, oh man, I can make my own 3D levels. And so how these tools function, how these tools work is completely up to the game, the tool programmer, and what they want the user to be able to do, right? This is the Warcraft 3 world editor, and this one, the game engine for Warcraft 3 was so powerful, and the level editor was so powerful. Who knows what industry spawned from this level editor? What's that? MOBA games, right? So Dota was a Warcraft 3 mod. that someone made in the level editor. Nobody went out and made a new game engine. It's just that Blizzard at the time was such a good company. They knew that there was so much emergent gameplay that came out of just giving players the tools. There were so many communities around map making and mod making and stuff. And so one of the most popular games of all time was just a mod that someone made in the Warcraft 3 level editor. Now, to give credit where credit is due, the first MOBA game was a StarCraft mod that was called Aeon of Strife, and it greatly influenced the creation of Dota. But Dota still, like, just imagine that that game and the concepts of MOBA in general all spawned out of just someone making a level in a level editor.
Reminds me of how a lot of FPS, including Call of Duty, to this day still have like Quake source code DNA.
Oh yeah, yeah. So lots of games borrow from others. Yep.
Didn't TF2 start as a Quake mod as well?
So
Like one did as well, yeah.
Team Fortress was a Quake mod. I played the original Team Fortress. It was pretty fun. And then when Half-Life came out, I can't remember the exact timeline. I recently watched a video about this. I'm not even going to say it because I don't know, but like Counter-Strike was kind of influenced by Team Fortress, and then that came out as a mod for Half-Life, but then got released with the orange box. So like, yes, lots of interesting games came out of users modifying games with these tools, not the companies releasing them. The StarCraft 2 level editor was insane. Like, you could make first-person shooter games in the StarCraft 2 level editor. It was absolutely nuts. And so these tools, they're so great. They usually come with their own scripting language. We'll talk about scripting and why that's important in another lecture. But my point here is, and Super Mario Maker. So, this is going to be one of the big inspirations for our game. But these tools are so vital to the community of a game. And like, companies now are just so greedy. They want to sell you a new level rather than you create a whole community around your game, and that's very sad. This is one of my, I think I'm correct in saying that this is a program called SpeedTree, or at least not necessarily a standalone program, but it may be a mod for game engines. This is one of my favorite things of all time. Someone got so good at writing algorithms to create trees that they formed a company around it. And so now if you want trees in your game engine, there's this thing called SpeedTree, and you're like, I want a forest with these properties. Boom, there's a forest in your game, right? And you can modify, like, it's fall now versus summer, or it's winter, or whatever. You can, like, I want the branches to be more scraggly, and it's all like procedurally generated and really nice. And so lots of tools for everything, even down to like a specialized tool for making trees in your game. So game tools are typically made along with a GUI of some sort. We've been using IMGUI in this class. Who, since starting using IMGUI, has seen it somewhere in the wild now? Everybody, right? So like, you see, okay, wow, this user interface is being used in a lot of places. So the first step, typically, to implementing some sort of good functionality inside a user interface system is this idea of dragging and dropping stuff around, right? Like using the mouse to be able to position things. So drag and drop typically refers to the ability to move some sort of on-screen UI element from one place to another. Like, imagine Photoshop without drag and drop. Like, how would you actually use the keyboard to like modify that, right? So in order to implement basic level editing, we can implement drag and drop via ECS really, really easily. Now, you don't need to do it this way. This is just one way of doing it. But what we can do is create the idea of a draggable component. Now, for the level editor, you do not need to have draggable components on your entities. But let's say, for example, as part of your gameplay, you wanted the ability for the user to like take a block and move it over there. I think I demoed that like really early on in the course. So let's say I want to click on an entity and move it. Okay, how would I pick it up, right? How would I implement that? Or for example, I could have something in a game where I have a mouse gun that shoots mice. And if the mouse hits the tile, now I can pick it up, right? Something like that. So if you have a draggable component that you have on an entity, maybe now when it's clicked, you can drag it around. Or if it doesn't have a draggable component, then you can't drag it around. So there are two variants of drag and drop from an implementation point of view. And this course is all about implementation. So a literal drag and drop would mean something like, I pick up this thing, and then I'm still holding it, because if I let go, I'm going to drop it, and that's what I do. I drop it over here. So the actual literal drag and drop would be something like when you click mouse down, you start to drag an entity. When you move the mouse around, you are moving the entity, and then when you release the button, you release the entity, and it just stays at that position. There's another variant that is a little bit easier to implement, and in my opinion, also a little bit easier to use overall, and that's sort of pick up and put down, where instead of the mouse button needing to be held to drag it, a full click picks it up, and then another full click drops it down. That way you can move it around in your game world, in your level editor, without needing to always hold down, especially if you're using a laptop. That gets really annoying, like having to hold it down and drag, especially if you need to scroll and you've got like 7 fingers on the mouse pad. It's just brutal. So let's create a draggable component. Literally, just a Boolean, right? Am I currently dragging this thing? Now, even though the draggable component only has one Boolean, there are really 2 things going on, right? Because yes, the draggable component says, am I currently dragging this entity? But the entity having the draggable component is almost like another Boolean saying, can I drag this thing, right? So there's like a hidden Boolean there, which is the does it actually have the component? So this is sort of the, in our input system, and this is all, it's a mix of pseudocode and C++, but essentially if the mouse button is pressed, what we might do is something like try and get the closest draggable entity to the mouse click position. Maybe that's a function that you have. Or maybe you just iterate over all of your entities and see if this click is in there. And you would say, okay, get the draggable component. If we are dragging, then D equals false. What does that mean? Well, it means that if I'm currently dragging something and I click again, then I'm no longer dragging it, right? But else if, so D is, okay, if I was currently dragging something, then drop it at this location. That's what that means. If I'm not currently dragging something, and the mouse was clicked inside an entity's animation, then now I'm dragging it. Okay? So it's pretty easy. If I clicked and I was dragging something, stop dragging it. Otherwise, if I'm not dragging anything, figure out if I clicked inside something and start dragging it. And then, in the drag and drop system, how do I actually move the thing around? Super easy. For all the entities, if it has a draggable component and I'm currently dragging it, just set its position to the mouse. That's it. So that's how I would implement it, and that's how I have implemented in the example that I'm about to show you. So I've got about 20 minutes left. I'm going to do a little bit of demonstration and a little bit of live coding, hopefully. But what I want to show you here is just how I have implemented, so this is essentially the solution for assignment 3. I've got the level editor here. If I go in and play, it's, okay, one second. This is not the solution. Make clean. Over here, I'm in A4. If this is one of those situations where it worked 20 minutes ago, maybe I didn't save. Hang on. Make run. Okay, so this is the solution code. But if I go back to the menu and I hit a secret key, I'm now in a level editor. Okay, so this is my default view for a level editor. It is almost identical to the gameplay scene. It's just there's no mechanics in it, right? So what I have done, and this is a little bit small, so I apologize, but over here inside my animations, let me just have a little quick zoom in here. So inside the UI, I've got some way of displaying all the different animations. Now, let's talk about, everything I say from now on is going to be broad strokes to help you design and implement a level editor. There are 2 ways that I view as possible ways to implementing this level editor. The first one is that no matter which animation I click, I drag it over into the level, I put it somewhere, and it's just an entity with nothing attached whatsoever. The second way would be that, for example, if I have this tektite animation and I create an entity based on that, then okay, I know it's a tektite, so when I pick up something and drop it and it's a tektite, I can detect that and then add all the things that I think a tektite should have immediately. So I would set its hit points, I would set its whatever, right? So that's one way of doing it. Another way would be literally, this is just an entity. Even if it's Link, it's not the player yet until I say it's the player, right? So let's just have a look at an example of this. I'll stay zoomed in for a bit because I think this is a little bit nicer. So for example, what I've done here is I pick up Link, so I'm going to left click it, and when I left click, by default, because my mouse is currently over an IMGUI element, so it doesn't have a position, it hasn't technically, while the mouse is moving over an IMGUI element in our game engine, the mouse moved event is not being called until I get out of an IMGUI element. So as soon as I move off of this, it's now on my mouse. And I've got this snap to grid, so I'm going to click off snap to grid. So if snap to grid is not clicked, then I can put this anywhere. If snap to grid is clicked, then I can put it somewhere. So I can also, oops, oh no, I've zoomed in so far that I've flipped the universe. So I'm going to exit out of that. Give me a second. Complete disaster. Let me rerun that. Oh my God. Ignore. All right, so go back into my level editor. Now what I can do is, okay, let's take one of these things. I'll put it over here and I can drop it. If I left click, I now have my entity selection. So let me zoom in on this. So I've modified this from how I demonstrated it in the last assignment video. So what I have now is that by default, what happens is when I click on an animation, well, okay, I'm going to create a new entity with that animation. So it has the animation, it has to. And it also has to live in the world somewhere. So what it has is it has a transform and it has an animation component, right? Everything else it does not have, but what I've added here is the ability to give it those things, right? So down here, this currently does not have a health component. So if I, let me actually put in Link over here. So I'll put in a Link, so this makes a little bit more sense. Put them there, now click it, so that I've got this one selected. So I can see that it has a transform component, and it has an animation component. I've got all the ability to edit those things down here. But of course, this is my player, so I want it to have some health. So I'm going to click Add Health, right? And all that does is add a health component. And then on the next frame, the GUI will detect, oh, it has a health component now, and it will draw that, right? So now I can set the health, and you can see over here that the health is actually being set correctly. Maybe I want to add a damage component. Well, this is a player, I should probably have a bounding box, right? So I'll add a bounding box. I want this to block movement and block vision. So now I've got the bounding box for my player. Since this is a player, so my input system is going to say, okay, any entity that has an input component is going to be controlled by the input, so I should definitely add an input component to this player. So now I've got the player. If I click off of here and then I click back, it just loads all those same things because that's just the components that it has, right? Now, not everything can be done via this level editor. The whole thing is that we build a game engine in another scene. This is my level editor scene, right? It doesn't have any game mechanics in it. Like if I drag this around, like if I turn off snap to grid and I drag this around, it's not colliding with anything in this scene because this scene has no mechanics. It's just level editing. So come over here, snap back to grid. So that's what it is. And then I'm going to have some sort of syntax for saving this to a file. I haven't implemented that yet. I'm going to build this over time, and in another lecture, maybe I'll show you the completed one. As you should be building this over time as well and not leaving it to the last minute. But I would have some way to save this to a file, and then I would exit out of the level editor, go to the gameplay scene, and load that level, right? So your gameplay scene, this needs to be saved in a way that the gameplay scene can then load it. You absolutely do not have to use the same syntax that I gave you, and in fact, it's probably easier, now that you have a level editor, to just save the exact positions of everything, not using this room and tile coordinate system, etc. Because the reason I used the room and tile coordinate system is because I wanted you to make a level with the file, right? And I don't want you to be typing in, okay, link is at 602.7, you know, that would be really annoying. So I made that grid system. Now, if I zoom out on the screen, I've also put something into this level editor where I can literally zoom out, right? So the level editor has this zoom out capability, and it also has, I can drag this around, right? So the level is infinitely big, but I'm just going to put restraints on the level. So for example, if I wanted, oh God, when I'm using I got to use the trackpad to do this. So if I want to, you know, create a level, I'm probably doing something like this, where I'm actually boxing Link in so that, you know, he can't escape into the arbitrary limits of the level. Now, if I did want to create limits that were not so obvious, maybe I could have invisible entities that prevented Link from moving there, etc. Here's another thing that I highly recommend. You see here that every time I come over here, I have to click it and then place a new one. Click it and then place a new one. One thing that I recommend for effective level editing, I was literally doing this like 2 a.m. this morning, right? So I didn't have time to do this, and I'll show this in a future lecture. But it would be much better if when I clicked this sort of was on my cursor, and now whenever I click, it puts it there, but then it's still on the cursor. I don't need to go back, because it's often that I want to repeat a bunch of these textures. So just imagine that I have this here, but then I can just go and like just drag a whole line of them. That would be much easier in the actual creation of levels. Something else is that each of these, now watch, well, I have to click on this. Okay, well, this is a wall. Does it have health? No. Does it have a bounding box? Certainly. So this is going to block movement, it's going to block vision, right? So it's got this black border around it, but now all of these don't. So something else that I didn't implement in time, but I highly recommend doing, is once you've got one of these entities set up, I would put in a button here that says clone. And this clone button would create a new entity with all the same component values as this entity and put it on the mouse cursor. So then I could clone this one and move it to a bunch of things. So if I have a bunch of Goombas and I've set up their AI, right, all those parameters, their health, their damage, etc., I could select clone and then just put it in a different part of the level. And so that is something that I would also recommend. And here, another thing that I don't have the ability to do is edit the tag. So right now, everything has the same tag of default. And so up here, what I should have is one of these IMGUI text entry things where I can edit the tag, right? Just be careful though, because what I've done here is when I added the entity, I didn't have an option for the tag. So this entity is created with the tag of default. So it is currently inside the entity manager under the default tag. If I change the tag here, I have no mechanism currently to move it to the new tag location. So for example, if I had the ability to change this to player, it would still be in the vector of all the default tagged things. So what you may want to do is like over here, maybe before you create an entity, be able to put in the tag somehow, or detect when you have changed the tag of an entity in the UI and then remove it from the vector of the old tags and insert it into the vector of new tags. Or inside the entity manager's update function, spend a little bit of extra computation to iterate through all the entities, see what its current tag is, and move it to the correct location if it's not currently in the correct location. So just be aware of that, because in the past that has tripped up some people, okay? So this uses a much simpler version of drag and drop than I just explained. This, so let's go over into the code. This is the make file, but this is my level editor. please have code there. Yes, it does have code there. So over here in the level editor code, so this is, I've created a level editor scene, right? So I literally copied and pasted the Zelda scene and removed all the functions. So I have all this stuff over here that I don't actually need, so I could remove that and it would be just fine. But what I have here, remember that selected entity that I talked about last time? That's the thing that's currently selected to draw the UI. But because this is a level editor, and it doesn't need to really operate within the ECS mechanic system, all I have here is a current drag entity. So this is the entity that the level editor is currently dragging. That's it. And so whenever I click in something, I just set that to the drag entity. And then over here in my actual code, so let's just have a look at that. Why not? I mean, I don't mind giving you some code here. So load level, I don't have any of this. I literally just copy and pasted this and then didn't fill it out. Do action. So now I have left click. So what did I do? Whenever I left click, first I say, okay, I've clicked again, so reset the selected entity. And what that does is that if I have something selected, whenever I click, it resets that. But if I click back on that same thing, it will just set that same thing. So like if I click over here, right, on this one, and then I click off of it, it unselects it. But when I click on it and then click on it again, it's like I never unselected it. But I actually did unselect it in the code, you just don't see it that reflected in the UI. So how did I do that? Really, really easy. I get the world position of my click. That's really important. I talked about that last time, especially in the level editor, because inside the level editor, I could be zoomed out like this, and I've got to get the world position of my click, not the screen position of my click. So I get the world position of the click, and then I just go through all the entities, and if that position of the click in the world coordinates is inside the entity's bounding box, then just pick it up. So I select, my selected entity is that. And then down here, in my mouse move function, or my mouse move action, because the game engine is detecting mouse moves and it's sending the mouse move action to this. Well, okay, get my mouse position again. And if I have snap to grid turned on, then just move it to the nearest tile position, right? That's just divide it and then multiply it. And then I add 32 because that's like the, you know, instead of it being on the grid crosshair, it's going to be in the middle of the grid. And all I have to do is, if I have a drag entity, so if I have the drag entity, set its position to the world position of the mouse. That's it. It's so easy to just select something as being dragged and then move it to the mouse on every frame. And then when I click it again, so I currently have the right click as my drag entity thing. So left clicking selects it to draw the UI, but right clicking it moves it around. You don't have to have that same thing. You could have any button press that you want. So okay, what's happening when I right click? Well, if I'm not currently dragging something, then this is where I should detect if something should be picked up, right? But if I am currently dragging something, then all I have to do is set that drag entity to nothing. And what will happen then is, because I've set the drag entity to nothing, then in my mouse move function, I won't be moving that entity anymore. So by setting drag entity to nothing, I've essentially just said stop moving that entity. So that's the dropping functionality. You don't need to set any positions or anything like that. It's just stop dragging it now, please. That's it. But if I don't have, I don't like this. Why is that up there? Okay. Oh, because this is the function signature or whatever. Just one second, I'll just finish explaining this. So if I'm not dragging an entity, then it's almost the exact same code. In fact, I copied and pasted it from up here, right? So it's a right-click version of this instead of left-click. And instead of setting the selected entity, I'm setting the drag entity. That's it. Just be careful to put this break in here when you first detect one, because what happens is if you have two entities overlapping each other, you could be dragging both, and so that could be a bad thing. You had a question.
Yeah, how does that interact with the draggable component? Because I don't see anything in there that when you stop moving it, that it will suddenly say dragging equals false.
Okay, so I didn't explain it well back then because I knew I was going to say this, but this has nothing to do with the draggable component. In my opinion, and the draggable stuff was from an old lecture, so I should have probably removed it, because that's how I used to say to do this. But components are for gameplay mechanics. So if you want a gameplay mechanic where you can drag stuff around, use the draggable component system, right? But this is the level editor, which has nothing to do with gameplay mechanics, and all I'm trying to do is move the position of an entity with the mouse. So this has nothing to do with the draggable system because they never interact. In the level editor scene, there are no systems for interacting with draggable components.
Okay.
Yeah. So this is the level editor scene. Draggable means nothing. Input means nothing. Collisions mean nothing. This is just a level, like I don't want to scroll through this. I don't want to give you all the code, but that is essentially what I'm doing here. And you can see now, so I'm not saying that you have to be as proficient with C++ or this engine as I am, but all of this, from opening it up to closing it, took about 2 hours, right? And that was figuring everything out, writing the UI, like doing all of that. So it's, with the ECS system, it is not a huge undertaking to do this, right? Probably the hardest thing, if I had never done it before, would be this system where I can drag around the level and zoom in and zoom out. So dragging around, zooming in and zooming out isn't hard, but getting it to zoom to the location of the mouse, that's a little bit tricky. Like right here, I'm zooming in and zooming out at that location of the mouse. Here, I'm zooming in and zooming out at that location of the mouse. That was the trickiest part there. You could just have a button that zooms in and pans around if you want to. I could have my arrow keys moving this around if I want, right? Maybe I don't want to use the mouse. And so it's so cool because using IMGUI in combination with ECS lets you add all of this stuff. Now, the last thing I want to mention is that yes, there still has to be coding going on, right? You have to implement all that behavior of the NPCs. You have to implement the physics system. You have to implement that pushing a button fires a bullet. But here's a cool thing, is that later on when we'll talk about scripting, we could add scripts to define that behavior in the level editor, right? So I could, for example, define what happens when I press left as a script. So the game engine, with all of its physics calculations and all of that kind of stuff, are all implemented in C++ super duper fast. But moving the player to the left is not a horrendously time-consuming CPU operation. So if I could maybe have a little script saved to a file, and then say, okay, that script is written in Lua or some other like high-level scripting language, then when I press this button, call this script, right? And so we could basically make the whole game's behavior within the level editor. And then we have a true game engine like Godot or Unity or something like this, where we could use the level editor and only the level editor to make a whole game, right? Now it would still have to have some of that physics stuff like built into the game engine, the loading of assets, that kind of thing. But it starts to get really powerful. Like imagine just starting with a blank screen and ending with a game and never having to write a line of code, right? That is the end goal of like an arbitrary game engine like that. So that's all I really wanted to show, because I talked about, in a previous lecture, I talked about how we pass mouse events to our scenes, and all of that is done in the game engine class. So that's key pressed. These are mouse button pressed, mouse button moved and released and stuff. And so since I did that in a previous lecture, that was where maybe 10 or 15 minutes of this lecture in a previous version was supposed to be.